Hello and welcome to the video on 6.4 and 6.5 for our statistical methods class. And I'm not going to get into too much of 6.4, but the concept here is this. If we have a population, there's generally two parameters that we're interested in, and that could be the mean of the population or the percentage or proportion from the population. Okay, so basically what this says is depending on, or no matter what the size of the population is, if you take a sample from the population, okay, if you sample from the population, as many samples as you're allowed to take, okay, so for example, in the homework, they said, well, your population is three objects in it, and if you let me say three is the population size. I mean, not use n because n is your sample size. Three is the population size, and you sample two out of those three. Okay, so you're gonna have nine possible samples. You're gonna have nine possible samples of size 2. Okay, no matter if it's a mean or a proportion. Okay, and what happens here is if you take a sample, okay, so let's say I take a sample from here, we'd get an X bar. Like I said, we'd have nine possible samples of size 2. So this X bar would be the average from the two that you picked. So we'd have nine of these. So it'd be X1, X bar 1, which is the average of the first sample, the average of the second sample, all the way to the X bar of 9, because you'd have nine possible samples. So basically what this is saying is if you take the average of all samples, X bars, if you take the average of all sample means, okay, divided by 9, because there's 9 possible samples, this is going to actually be equal to mu. Okay, this can be actually equal to the population mean. So this is called the average of all X bars is equal to the average of the population. So these are the average of all possible samples that you could take from a population is equal to this if X bar is an unbiased estimator. Okay, so that's what we say. Now if let's say, see, this is a mean, so if you have a proportion, so say n is equal to 3, and I'm sorry, did it again. For your population, this is the percentage from your population. Okay, so this is the percentage from the population. Okay, so if we sample from this population, so we have a population size 3, so 3 is the pop size, we'd have 9 possible samples of size 2. Okay, so in this case, when we sample out of a proportion population, the statistic in this case is p hat. P hat is equal to the number of successes in n in your sample, we say in your sample, divided by the sample size. Okay, so in this case you'd have 9 p hats, so it'd be p hat 1, p hat 2, p hat 3, all the way to p hat 9. If you take the average of all these p hats, which we call it this, okay, so the average of all the p hats would be p hat 1 plus p hat 2 all the way to p hat 9. See, because every p hat is going to give me a percentage from the sample. Okay, this is n equals 2. This is going to be equal to the sample percentage. So this to the population percentage. Okay, so the average of all the sample proportions is equal to the population proportion. So that's saying mu of all the p hats is equal to p if p hat is an unbiased estimator of p. Okay, so you're gonna have to practice at a lot of these and just go through, and you just take the samples, you'd find the proportions, and if it was a percent problem, if it's a mean problem, you just take the samples, find the mean, get the average of all the means, and they will be equal. Okay. Okay, so let's go to 6.5. And what 6.5 does is it introduces an important concept called the sampling error. Sampling error, or sometimes we call it sampling variation. It's a very important concept. Okay, so what this means is, and this chapter just deals with, means. Okay, eventually we'll be doing this. So basically this means if you take a sample of any size, we're going to get an x bar. Okay, call that x bar 1. Now, no matter what size it is, let's just say it's 100. If I reach in here and take a different 100, okay, so it's a different 100. So this 100 is different from this 100. It's not the same sample. That's going to give me a different number. Okay, possibly. Most likely this x bar 1 will be close to x bar 2, okay, but probably not equal. I think everybody could agree that that's just common sense. If you take two different samples, you're probably going to get different results. And the same thing goes if I take an x3, an x bar 4, and so on and so forth. Okay, so the sampling error is the variability of all the x bars, which all the sample means. So what this means, if you think about variability is like standard deviation. That's how we measure the variability, standard deviation. So what this is saying is how much can we expect these x bars to vary? Okay, so we have this theorem called the central limit theorem, which is important. Central limit theorem that tells us that if n is 30, around 30 or more, okay, the distribution of all the x bars will be normal. Okay, will be normal. That's the graph of all these x bars. So now this is similar to getting it. These problems are going to be similar to 6.2. So see, now these aren't x's anymore. They're the averages. Okay, and like I said on 6.4, we're on 6.5. What's the average of all these x bars? The average of all these x bars is the same as the average from the population. Okay, so if you take an x bar, an x bar, an x bar, an x bar, all these x bars, if you get the average of all these x bars, it'll actually be equal to the population. So the distribution, the average of this distribution will be that guy. Okay, so this is normal, and the mean is this. But what's the standard deviation? Okay, what's this? How much can you expect these x bars to vary? Okay, so what happens here is that's what the sampling error is. The sampling error is the standard deviation of all these x bars. It's how much do we expect these x bars to vary from each other? Well, when you take samples of a certain size, what happens here is these x bars will not vary as much the more you take. Okay, so the bigger your sample size, the less the x bars are going to vary from each other. Okay, so the standard deviation, that's what this stands for. The standard deviation of all these x bars is actually equal to the original standard deviation from the population, which is this guy, from the population, divided by the square root of n. Okay, so it actually goes down by this much, by the square root of n. So for example, If my original standard deviation from the population is 25, okay, and the mean is, let's say, 100, then, see, this is from my population. This is from my pop. So what that tells us is that if I come over to here, this is the sampling distribution of all my x bars. So what happens here is these x bars aren't going to vary as much as this. So let me draw my population over here. So this is my pop. So these are all my x's. So this is normal with 80 and 25. So any given person could vary a lot from 80. It wouldn't be out of the ordinary. Okay, let's just say somebody comes 90. Let's say somebody gets a 105. Okay, let's somebody gets a 105. That's not that out of the ordinary because it's only one standard deviation. This is only one standard deviation away. But what happens if you get an x bar? Can you get an x bar, an average of 105? Let's say we take, oh yeah, I want this to be a little lower, but all right. Let's say I take 100 people. Do you think the average of 100 people, are going to be greater than 105? Okay, so what happens here is the sampling distribution of x bar is going to be, has less variance over the square root of n. Because the variability of these x bars, these x bars aren't going to change as much as these x's. Okay, because you're taking 100. Just think about it. If you take 100 people and get the average, okay, and the real average is 80, this x bar that you take, these x bars here, all these x bars here should be really, really close to 80 if that's really true. Okay, so these x bars are all going to be really close to 80, so they're all going to be packed around here. This is 80. All these x bars are going to be packed around. You're not going to have many that are far. Okay, so this is going to be normal with 80 and 25 over the square root of 100, okay, which is 10. So this is going to be normal with 80 and 2.5. So look at, these vary by 25, but these here, these x bars only vary by 2.5. Okay, so if you think about 2.5, then that means that you're not going to get an average. See this average here? Look down here. This average, what happens if you get an average of 86? Okay, if you get an average of 86. So how many standard deviations away is that? So you go 2.5. 2.5 gets you to 85. So 85, an average of 85 is way over here. So an average of 86 just isn't going to happen that often because it's more than 2 standard deviations. But look at, can you get one person that's 86? Can you get one person that's 86? Heck yeah. Yeah, very easily. 86 is really normal. So for one person to be 86 is normal. To get an average of 86 is abnormal because when you take more people, you have less variability. So the sampling error is the variability, the standard deviation within the average of your means, or within the sampling distribution of your means. Okay, so now let's get into the homework problems. They're very simple. If you go to StatCrunch, here's your mean, that's your standard deviation, and it's the probability that x is greater than or equal to. These are going to be your x bars now if you take a sample. If a sample is taken equal to, and this will give you the percent. Should be comfortable after doing the last ones. Make sure that you understand, okay? So the sampling error, the mean, I'll let you guys do that one. Let me just look at it one more time. Okay, that just defined that for you. So let's look at this. This is a review question. They're giving you a mean of 62.2. Let me okay, so I'm good. So they're giving you a mean. This is the population, 62.2, standard deviation of 2.6. That's my population. If one person, so a sample is not taken, so I'm in my population right now. So this is a review. Okay, so let's go to the next one. Okay, 10 people. Okay, the capacity will be exceeded if 10 people have weights greater than 1670. Okay, so how many people am I taking? My n equals 10. Here, let me get this. This is my stat crunch. Well, that was the problem from before. So this was the problem from before. I'll just write it for you real quick. If one person find the probability that the weight is between, so these are the ones that you kind of have to play with a little bit, because it's between 61.5 and 62.5, which is over here. And I want between. So this is one of the ones, if you watch the other video, you have to find this, and you have to find this on StatCrunch, and do 1 minus, you have to add these two together, and take away 1. That's the answer for this one. Okay, but now, what's happening is we're taking a sample. Okay, so as soon as we take a sample, we're not in the population anymore, we're in this, what's called the sampling distribution. So let's define what our mean is. Okay, so if you took 10 people, what is the average of all those x bars? The average of all those x bars will be the same average as your population. Okay, the standard deviation is 32 pounds, but if you take 10 people, okay, lifts 10 people, so the new standard deviation is going to be 32 divided by the square root of 10, greater than 170 pounds, or 100 and, what's the probability that the, oh, this is just one person. Okay, so see, one person's 167. I'll do this one right here quick. I thought it was out of the 10 already, but it's not, because it's saying find the probability that if a person, I didn't take a sample yet, that his weight will be greater than 167 pounds. So here's 170, that's 167, and it's greater than. Okay, so this is going to be mu equals, this is a review, you've done this already. Erase what I just wrote. That's the mean. The standard deviation is 32. So this is going to be the probability that x is equal to or greater than 167, and here's your answer. Let's see if this is working. Okay, stat. This is a review. Calculator, let's go to normal. Okay, so this is the problem on right down here. I need the mean to be 170, because that's my mean. I need the standard deviation to be 32. I need this shaded region to be greater than, see, greater than, and I need this red to be 167. 167 to the right. Okay, so it's 0.5373, that makes sense to me. Round to 4 decimals. Round to 4 decimals, so that's going to be 0.5373. Okay, make sure I rounded right. I did. Okay, so now it says find the probability 10 randomly said the mean will be greater than 167. The mean will be greater. Okay, so only one thing changes here. Oops, the mean. The mean. So it's the same exact idea, but I'm not dealing with samples anymore. So you have to get this concept. Okay, what would the average of all these x bars be of sample size 10? Well, if it's unbiased, the average over these x bars will be equal to mu. So this would be normal with mu. How much will these things vary? What's the standard deviation? It's not going to be this much. There's no way near. It's not going to be this much. It won't be near that much. Okay? They're not going to they're not going to bounce around like these x's are. See, these are all just x's. These x's will bounce around a lot because there's a lot of variability if you just pick one person. But if I take 10 people, they all knock each other out. Most of them fall within a smaller range than these guys. Okay? So the standard deviation is going to be the original over the square root of n. Okay? So the standard deviation of all the x bars equals the original over the square root of n. Okay, so this is going to be mean. So now you need to go to your stack crunch, and the mean is going to be the same, 170. But the standard deviation is going to be 32 over the square root of 10. So what you have to do is you have to go to your calculator, and you have to find this. Calculator. I'll do it on my calculator. Okay, so you have to do 32 divided by root 10. Okay, and then I'm going to write this number down. Make sure I'm on top here. Yep, I'm going to write this number down. You do not want to round this number. So standard deviation is 10.11928851. Now here, this is the same mean, so this is going to be 170. I want 167. I want to shade to the right, just like this one, the same exact thing, but I'm not taking one person, you're taking 10 people. Okay, so this is going to be the probability that x is greater than 167, and here's going to be your answer with this new standard deviation in there. Okay, so let's go to my stat crunch. Sorry, I have so much stuff here. Try to make it watchable for you. Okay, stat calculators, normal. Okay, so my mean is going to be the same, 170. The only thing that's going to change is the variability, which is going to go down to 10.11928851. Okay, now all this other stuff's going to be the same. And compute. Make sure I'm good. 167 to the right. Okay, so 61% of the samples will be greater than 167. Okay, so I need to round this to 4 decimals. So that's going to be 0.6166. 4 decimals. Make sure 4 decimals. 0.6166, and that'll be right. Nice work. Okay, so make sure you know the difference. Make sure you know the difference between a population distribution and your sampling distribution. Okay, sampling distribution is if you take a sample. The only thing that changes is going to be the standard deviation. Everything else will remain the same. Let me see how much time I'm at now. Okay, not too bad. Okay, so you guys could just answer that question. That should just be common sense. Okay, so here's the same thing. Find the probability that her. So you have to do this on one. So this question's a review. This one's a review. Okay, if I answer this, okay, which I'm going to answer this question on this calculator, okay, because it's just quicker to do on this calculator. Okay, look real quick. If you were going to do it on this one, oops, I didn't want that to disappear. That wasn't the question, no. So if you were going to do it on this question, the average would be 114.7. The standard deviation on StatCrunch would be 13.3. 13.3. Okay, now this is a between problem, so this would be 18, this would be 24, and the middle is 13.3. So I want to find this area in the middle. I want to find this area. This is the goal, but StatCrunch doesn't have anything like that. So what you have to do is you have to use the StatCrunch to find this area, which we'll call, that would be A. You need to find this area, which is B. You need to add those together and subtract 1 for that. Okay, On this calculator, it's a little bit easier. So we'll go second vars, okay, normal CDF. Now I want to put my lower limit, which is 18. Okay, my lower limit, 18. I want to put my upper limit, which is 24. I want to put my mean, which is 13.3. And I want to end it with let me show them right, comma, 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 standard deviation, which is, okay, sorry, I got my mean mixed up. Something's wrong. H's. Oh. That's what I get for not reading the question. Got mixed up. Okay, so this is even easier. Okay, we can do this one in StatCrunch. This problem doesn't have anything to do with ages. Okay, so this is normal. Okay, the mean blood pressure, which one? Systolic is 114.7 with a standard deviation of 13.3. Okay, so just forget about everything I just said. 1. And I want it to be greater than 110. So here's 110. Okay, so I want to find this area here. Everything off to the right here. Okay, why don't I use the cooler thing, if it'll let me. Okay, it won't let me. Okay, so I want all this to the right. So I'll just do it on this. Okay, so I want my lower limit to be 110. You should be good at doing this on StatCrunch now, because this is in the middle problem. Let's pick an upper limit of a systolic that could never happen. Way over here. Way over here. Let's go ahead and put the mean, which is 114.7, and the standard deviation, which is 13.3. I get a problem here. Oh, I see my problem. It's CDF, not PDF. It's CDF. I accidentally hit 1 instead of 2. Okay, CDF. Maybe 11. Okay, here we go. So round to 4, so 6381. 0.6381. Okay, because the 9 rounds is 0 up to 1. Okay, so now if four people, okay, so if you take 4 people, that's going to cut your standard deviation in half. Okay, so this is the same exact problem. Okay, so I'm going to open this problem up in StatCrunch. But do you see the difference? This is your population. That's my pop. But once I take a sample, take an equals 4. Now these aren't x's anymore. See, these are all x's. These are all one person between that age group that they gave you. But now this is going to be the average of 4 people. Okay, so these are all going to be x-bars now. So they're not going to vary as much. Averages do not sample as much as individuals. I cannot stress that more. The mean will stay the same. So this is going to be normal with 114.7, a standard deviation of 13.3 divided by the square root of 4. Square root of 4 is 2. That's why I was saying that it cuts this thing in half. Okay? So if I want to pull this problem up, everything's the same. It goes from 110 to some big number, 1114. The only thing that's going to change is this guy. And what I'm going to do is put a parenthesis around this. I'm going to put divided by 2, close parenthesis. Okay, so 76. Okay, so I'm going to show you how to do it on StatCrunch. So on StatCrunch, it would be 114.7. The standard deviation would be 13.3 divided by the square root of 4. You want the probability that x is greater than 110. It's the same exact problem. Just in this, this is 110. And it's going to give you the answer, which should be 0.76. So all I need to do is 13.3 cut in half. Okay, so this is going to be on our StatCrunch right here. So this is equal to 6.65. So I'm going to show that in case you're wanting to do any of this stuff. Stat, calculators, normal, or a normal distribution. Let's pull this out of the way. Let's pull this out of the way. I know it's a little messy. So my 114, my mean, 0.7. My standard deviation is 6.65, and I'll remind you again, it's the original divided by the square root of 4, which is 13.2 divided by 2. Okay, so now here, I want this thing to be a greater than, see, because it's greater than. Okay, this thing needs to be a 1110. I'm in raw data. This is at SAM. What's the probability that the sample will be greater than 110? Okay, 0.7601, same thing. We need to round to 4. 7601. So it's 0.7601. And that'll be right. Okay, so you guys could just play around with that. Watch this thing over again and over again. And the biggest concept here is to know that the sampling error, or the sampling variation of the x bars, is equal to the standard deviation of the sample means, and that the variability in the x bars will definitely be less than the variability of the x's. Okay, so thanks for watching and good luck.